Here we'll talk about how to classify triangles. We'll start by classifying the triangles by the type of angles that we see. Let's start in the middle with this triangle that has a right angle inside of it. Recall that a right angle doesn't specify the direction in which the angle points. It only means that one of the lines is straight up and down and the other is straight left and right. The word we use to define those lines is perpendicular. Sometimes we abbreviate perpendicular lines with this T shape I'm drawing here. Anytime you have two perpendicular lines, you will get a right angle. And the measure of a right angle is automatically 90 degrees. Anytime you have a triangle where one of the angles is a right angle, it's called a right triangle. Inside of a right triangle, you will always have a 90-degree angle, and you'll have two angles that are smaller. If we go to the left-hand triangle and examine the angles, we may be able to see that all of them are sharp and pointy, and that would mean none of these angles are greater than 90. They're all smaller. If all of your angles are smaller than 90 degrees, what you get is an acute triangle. Just as how an acute angle is less than 90, an acute triangle has three angles that are all less than 90. Let's compare that to the triangle on the right now. We may be able to see that we have one very large angle in this triangle and two very small ones. The larger angle, we can tell, is going to be bigger than 90 degrees. If we have an angle that's bigger than 90 degrees and the other smaller, this is called an obtuse triangle. This matches up with what we know about obtuse angles. Obtuse angles mean bigger than 90. So acute triangles will be sharp on all sides, but an obtuse triangle will be big and bulky on one side. So these are the names we give to triangles based on the angles they contain. Let's now classify triangles by their size of the sides. If we look at the triangle on the left, we may note that all of the sides are the same. Each of them measures exactly 7 units. If all of your sides are the same, you're called an equilateral triangle. Interestingly, we could also look at the angles and note that all of the angles seem to be smaller than 90 degrees. So it would also be correct to call this particular triangle an acute triangle as well. We could say this is an acute equilateral triangle. Acute describing the angles and equilateral describing the sides. If we look to our second triangle, we can see that two of the sides measure 10, while the longer side measures 14.1. So this triangle has two sides that are the same and one that's different. A triangle that has two sides that are the same is called isosceles. Note also that this particular triangle also has a right angle inside of it. We can tell that because of the box in the corner. Therefore, this particular triangle will be a right isosceles triangle. Now be careful here, because not every isosceles triangle is right, and not every right triangle is isosceles. A right triangle can have all different sides if it wants to. And an isosceles triangle doesn't necessarily need a right angle. Remember that isosceles refers to the sides, but right refers to the angles. Now we look to the final triangle, and we look at the length of its sides. We can see that we have a 20, a 23, and a 35. This means all three sides are different from one another. When you have three sides that are all different, we call this a scalene triangle. Also notice that we have a large bulky angle in the bottom of it. This is definitely going to be greater than 90 degrees, even though we don't know what it is. We can tell it's larger than 90, and so we'll call this an obtuse angle. Therefore, the triangle on the right is an obtuse scalene triangle. Note that any triangle can turn out to be scalene if the side lengths are different, but you have to have that larger angle in order for it to be obtuse. So remember that scalene refers to the sides and obtuse refers to the angle.